Important to note that when we talk about organic chemistry, we're talking about the study of compounds that have carbon as the building blocks, so long chains of carbon molecules. Sometimes there are other elements added in, but the main idea is that it's built mostly of carbon. So sometimes we have oxygen and nitrogen and sulfur, and usually a lot of the halogens, but for the most part it is carbon only. So now we can draw what we call a condensed structure. So I'm leaving out all of those lines and I'm just drawing the structure as small groups. So I'm taking that first group of carbon and its hydrogen and I'm writing it as CH3. I'm taking the next group of hydrogen and I'm writing it as CH2, and so on and so forth. So you can see each group of carbon and its hydrogen gets put together, so I get a much more neat structure called a condensed structure. So whenever I have a branch in my chain, then I still am going to draw that branch in my condensed structure so that it kind of illustrates what's happening away from the main chain. So let's try a few. Okay, here we go. So here are three structures. So what I want you to do is kind of group together carbon and each of its hydrogens that go with it. So if we're starting with the first one, I'm just going to kind of draw them on there as we go. So I've got this first group of hydrogen and its carbon. So that one would be CH3. And then I'm going to move over to the next group in the main chain, which is CH. And then the next one, which is a CH2. And then the next one, which is a CH again. And then the last one, which is a CH3. And then I'm going to look at my branches. So in my branches, off that second one, I've got a group of CH3. So I'm actually going to take the second one and I'm going to draw that branch and then the CH3 group. And again, on the next yellow one, I've got the branch of CH3 again. So I'm going to draw the branch of CH3 again. So that's what the condensed structure would look like for the first one. Okay, let's try the next one. So again, just breaking my chain up into the carbons. So I have CH3, CH2, CH2, and then I've got that oxygen stuck there in the middle with no hydrogens, CH2, and then a Cl on the end. Okay, so that structure is one long chain. There's no branches there. And again, for the last one, instead of H's, I've got F's, but I'm just going to do it exactly the same way. So I've got CF3, CH2, and one F. And again, if I've got more than one type of atom bonded to that C, I'm always going to put the H's in there first, and then what we call the extra substituents on the next one. Okay, now there's an even simpler way to draw these molecules, which is called a skeletal or line structure. So the most important thing for you to remember is this part here. Every end and every bend to the line represents a carbon. And we're leaving off all of the hydrogen bonds and all of the hydrogens just to make the structure that much simpler. But again, the rule of thumb, every end and every bend represents a carbon. So when I look at these structures, I want you to try and locate the longest chain. So I'm looking for the longest chain, and in a few days, we'll talk about the fact that the longest chain has to contain those double bonds and those extra substituents. But for now, my longest chain is 4 carbons long. So it doesn't matter if I do it that way or if I went this way. Either way, it's 4 carbons long. So with my chain, every end and every bend is literally going to look like that yellow line. So as soon as you put your pen down, that's 1, 2, 3, 4. So in that structure is 4 carbons. Here's carbon 1, carbon 2, carbon 3, and carbon 4. So now I just have to pay attention. I'm going to ignore all the hydrogens. So the hydrogens would be 3 here, none here, 1 there, and 3 there. I also have to add that double bond. And what I notice is the double bond is carbon number 2 to carbon number 3. So in carbon number 2 and carbon number 3, I have to put that double bond. And then I've got this extra carbon group hanging off the end here, so I need to draw that as my branch. So again, it's 1, 2, 3, 4, double bond between 2 and 3, and an extra branch at carbon 2. These will quickly become your favorite structure as they are much simpler to draw than the other ones. Okay, so for the second one, again, I'm going to look for my longest carbon chain. So we can do it the easy way and just go straight across. 1, 2, 3, 4, 5. Or I could go from the bend, but you will notice it'll look exactly the same as if I started from one of these carbons down below and did the longest chain. So just try it a couple times with your finger. You're looking for the longest carbon chain, and I can't get more than 5, so it doesn't matter which 5 I choose to be the longest because there's no double bonds in this one, as long as there's 5. So I'm going to start with my 5 carbon chain. So put your pen down. That's 1, 2, 3, 4, 5. And then I have to look at what is on that main chain. So off carbon number 2, I have a methyl group or a 1 carbon group. And off of carbon number 4, I have the same. So in my structure, off of carbon number 2, I'm going to draw 1 more stick to represent the extra carbon. And off carbon number 4, I'm going to draw the same stick to represent that methyl group, that 1 carbon group. Okay, so now how do we go backwards? Again, we're looking for the longest carbon chain. So 1, 2, 3, 4, 5 is the longest carbon chain. So I'm going to draw exactly that chain. 1, 2, 3, 4, 5. And then I also notice at carbon number 2 to carbon number 3, I have that double bond. So I need to put that double bond in at carbon number 2 to carbon number 3. And then I take a look and I got this little extra carbon group hanging off here and this little extra carbon group hanging off. So at carbon number 3 and carbon number 4, I've got that extra group. So carbon number 3 is going to have another carbon, and carbon number 4 is going to have another carbon. It doesn't matter whether I draw them up on the same side or opposite sides across a single bond. Basically, just for space, I'm going to draw them this way. So now I've got my carbons all in there, and now all I have to do is fill in the hydrogens. So 1 hydrogen here, 1 here, 1 here. That's 4 bonds for that carbon. This one's got 3 already, so we can only have 1. The one up here needs 3 hydrogens. This carbon right here has 4 bonds already, so I'm going to leave it be. This next carbon only has 3. Hold on. So it needs an H. Sorry. And then this one needs 3 H's. And this one needs 3 as well. So there is the structural formula, which again is the biggest diagram you can draw, of the bonds for that particular molecule. On the next slide, you will find a video that basically goes over what I just went through on how to draw these structures. And then on the last slide is your needs an H. Whoa, sorry, assignment. So in our Schoology file, you will find an assignment as some practice for drawing organic molecules. So there are the three types: structural, condensed, and line diagrams. Give it a try, see if you can move back and forth between them. If the boxes are not big enough for you, feel free to use lined paper. And then you're going to take a picture and submit it to me as best you can. And we're going to try this out. This assignment is due on Friday. So I want to make sure that I can see that you're drawing them correctly before we move on into anything a little more complicated. Okay, have a good day.